out of all quadrilaterals, and that's a square. So, let's put the definition. A square, this is card 94. A square is a parallelogram with 4 congruent sides and 4 right angles. So let's put the properties. It has all of the properties of a parallelogram, a rectangle, and a rhombus. So it has all of the properties of all of the shapes. So let's see if we can draw this one properly. All right. Let me think for a second. If I want to make the square an inch long, that's going to use up 4. If I want to make 4 along the top, that's going to take up 4 inches. And I would need 1, 2, 3, 4, 5 spaces in between them, on the edges, and then 3 in between. So with 2 inches left, if I divide that by 5, right? I get about 0.4 of an inch. Alright, so I'm just going to go ahead and do what we've been doing instead. I'm going to go a ½ inch away. I'm going to make this an inch long. Same thing from this side. And then I'm going to do the middle. And then we'll just put the other one again below. Now I got to go an inch down from that. Right? So I'm going to make a mark an inch down on each side. And I got to do the same thing. Okay. So now I just got to connect all of my sides. Alright. So I have A, B, C, D, A, B, C, D, A, B, C, D. Now I know that all 4 sides are the same length, right? And I have 4 right angles. And I know that the opposite sides are going to be parallel. Let's see if there's anything else that I want to put in this picture. Let's see. No, I think that's good for now. So first let's put that angle A is congruent to angle B, is congruent to angle C, is congruent to angle D. All four angles are right angles. And also AB is congruent to BC, is congruent to CD, is congruent to DA. We also know that AB is parallel to CD, and BC is parallel to AD, and angle A plus angle B equals 180 degrees. Angle B plus angle C is 180 degrees. Angle C plus angle D is 180. And angle D plus angle A is 180. Alright? So that covers a lot of the basic properties. Now let's talk about some more of the properties that deal with the diagonals. Now this is going to combine all the diagonal properties that we've talked about so far. So this is going to be pretty interesting. Let's see how we can keep this clean. Now, first let's write an E here. And we know we have four right angles here. And since the diagonals are congruent, which is the property of a rectangle, we know that they bisect each other. And each one of these pieces is congruent. And we also know, let's see, we also know that it's going to cut each angle into congruent pieces. So I think that covers it. Let me just double check by looking at my other quadrilateral drawings. Okay, so let's put AC is perpendicular to BD, forming four right angles at E. Let's also put that AC is congruent to BD, and AE is congruent to EC, which is congruent to BE, which is congruent to ED. And let's label these angles, these small ones. 1, 2, 3, 4, 5, 6, 7, 8. Angle 1 is congruent to angle 2, is congruent to angle 3, is congruent to angle 4. Is congruent to angle 5, is congruent to angle 6, is congruent to angle 7, is congruent to angle 8. Alright. Is there anything else that I'm missing? No. Now let's go back to this side. Draw our diagonal here. And we could say triangle ABD is congruent to triangle B, C, D. This is a C. Now let's draw one more square. A, B, C, D. So triangle ABC is congruent to triangle ACD. Okay? So we got all the properties of most of the quadrilaterals, but we still have to talk about the next two, which are the trapezoids. This would be card 95. Let's see, trapezoid. Give me 1 second. Okay. So let's start with just the basic trapezoid. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. One pair of parallel sides. Okay? Let's see. There's another property that's really important, and that's that the median, also called the mid segment, of a trapezoid is parallel to the bases and equal to one half the sum of the bases. Let's see. Okay, that's it. Let's draw a picture for the trapezoid. Alright, now we only need one picture for this because we could fit all the information into one picture. So I'm going to go from 2 to 4. I'm going to go down a little bit. And I'm going to go 1.5 to, let's see, 5.5. Okay. So let's see, label this A, B, C, D. All we know is that one side is parallel to the other side. And these sides that are parallel are the bases. Okay? That's all the properties of a trapezoid. But We can also connect a mid-segment. So if we connect the midpoint of this line, so if this is 1 1/4, that would be right here. And this, let's say, the middle of that line's like right there. So now let's connect those 2 points. Let's call this EF. This is also going to be parallel. This is called the median or mid segment. And since it's a median or a mid segment, it also breaks these sides into congruent pieces like that. Okay? So here's what we know. We know that AB is parallel to EF, which is parallel to DC. Okay? So the bases are parallel and they're parallel to the mid-segment. We know that segment AE is congruent to segment ED. We know that segment BF is congruent to FC. And we know that the length of EF, the length of the mid-segment, is equal to 1/2 the sum of the bases, AB plus DC. Okay? That is what we know about a regular trapezoid. That was 95. Now we're going to talk about the isosceles trapezoid, which is on 96. Okay, let's see here. An isosceles trapezoid. Is a trapezoid with congruent legs. Let's just go back to 95 for a second and let's label the legs here. Okay. So the ones that are angled are the legs and the ones that are parallel are the bases. So this is card also 96. Okay. So for the properties, it has one set of parallel. Well, hold on 1 second. Yeah. It has all of the properties of a trapezoid plus the base angles are congruent. The legs are congruent. The diagonals are congruent. And the opposite angles are supplementary. Alright, so now let's draw some pictures. Now let me think of how many I want to draw for this. probably want to draw 4 pictures for this, believe it or not. So let's see how I can do that. Let's divide this in half, vertically and horizontally, and we'll draw 4 pictures of an isosceles trapezoid, 1 in each box. Okay. So I'm going to go close to the top here, and I'm going to go from 1 to 2 and 4 to 5. And I'm going to go down a little bit, just like that. I'm going to go from a half to 2.5, and from 3.5 to 5.5. Come down here and do something just like that. From 1 to 2, 4 to 5. Oops, went a little far. Okay. Go down a little bit. And I'm going to go, oops, hang on a sec. Just like that. Okay. So AB, CD. So first we know that these sides are parallel. Now in an isosceles trapezoid, the legs are congruent and the base angles are congruent. So I think that's good enough for the first trapezoid. So let's just write down AB, whoops, AB is parallel to DC. Angle D is congruent to angle C. Angle A is congruent to angle B. AD is congruent to BC. And we also know that angle D plus angle B equals 180 degrees. And angle A plus angle C equals 180 degrees. Let's just see if there's anything else we could add in here. No, that's good enough for the first one. Now, for the next one, let's put in the median. looks like it goes right about there. I'm just going to eyeball it. Okay. So this is A, B, C, D. We also have the same properties that we talked about before. Okay, let me see. So we know AB is parallel to EF, which is parallel to DC. We know that AE is congruent to ED. We know BF is congruent to FC, and EF equals 1/2 the length of AB plus DC. Okay, so that deals with our mid-segment stuff. Now, let me see what else we want to put here. Let's see. The diagonals are congruent. Alright, so we really only need 3 pictures, it looks like. So this is A, B, C, D. We also know that AC is congruent to BD. Okay? And we don't need this last picture. So, there you have the properties of an isosceles trapezoid. And that was card 96. Okay. Alright, this is, we're going to go over the theorems, the quadrilateral theorems. So, this is card 97. And let's call this parallelogram theorems. And let's call it part 1. So we have a parallelogram is a quadrilateral. With both pairs of opposite sides parallel. Actually, hang on a second. Yeah, of opposite sides parallel. Then we have if a quadrilateral is a parallelogram. Comma, then the 2 pairs of opposite sides are congruent. Then we have if a quadrilateral is a parallelogram. then the two pairs of opposite angles are congruent. Then we have if a quadrilateral is a parallelogram. Comma, then the consecutive angles are supplementary. Okay, let's see. Let's put a little, let's finish on the back. Well, we'll finish the first part here. If a quadrilateral is a parallelogram, then the diagonals bisect each other, so comma, then the diagonals bisect each other. And then if a quadrilateral is a parallelogram, then the diagonals form two congruent triangles. Okay, that's enough for this card. So now let's go to card 98. And we'll do parallelogram theorems part 2. Okay. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. Actually, let me think about this for a second. Yeah, that's fine. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. Now, a lot of this may seem repetitive, but they're just slightly different versions of the same thing, some of them. So with both pairs of opposite sides parallel. If both pairs of opposite sides of a quadrilateral are congruent, so if both pairs of opposite sides of a quadrilateral are congruent, comma, then the quadrilateral is a parallelogram. if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. If one angle is supplementary to both consecutive angles, in a quadrilateral, then the quadrilateral is a parallelogram. And we're going to need two more theorems on the back. The first one is, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. And we have one more. If one pair of opposite sides of a quadrilateral are both congruent and parallel, comma, then the quadrilateral is a parallelogram. Okay, let's see. For card 97, up here next to the top, put, let's put in brackets right next to this. Let's put, given a, let's make that a lowercase g. No reason that should be capital. So when we're given, these are theorems for when you're given a parallelogram, and card 98 is for theorems when you are trying to prove. So let's put proving a parallelogram. Okay? Next card. It's card 99. Just double check that. Yes, card 99. Now we're going to talk about the theorems for... Hang on one second. Let me just double check this. Yes, so... Now we're going to talk about the rectangle theorems. Okay, so we might be able to fit a couple on this one actually. A rectangle is a parallelogram with 4 right angles. Let me just see something here. Let's put rectangle, rhombus, and square theorems. Okay? So a rectangle is a parallelogram with 4 right angles. We remember that from the definition. We can also say a quadrilateral is a rectangle. If and only if it has 4 right angles. Now we can say if a parallelogram has 1 right angle, it is a rectangle. A parallelogram is a rectangle if and only if its diagonals are congruent. That's it for the rectangle ones. Now, let's go to the rhombus ones. A rhombus is a parallelogram with 4 congruent sides. A quadrilateral is a rhombus if and only if it has 4 congruent sides. Okay, let's turn this over. And we need to fit Let me see. 1, 2, 3, 4, 5. So I got to break this up into 5 parts. So I want to make sure I leave enough room. So let me think here. Let's see. Let's see if I do. So let me just check something. It's close enough. I'm dividing it into every 7/8 of an inch. I'm putting a mark. So if you want to watch that again, this is 1/8, 2, 3, 4, 5, 6, 7/8, and 1, 2, 3, 4, 5, 6, 7/8. 1, 2, 3, 4, 5, 6, 7/8. 1, 2, 3, 4, 5, 6, 7/8. And it leaves me a little bit less room on the very bottom, but I'll just have to make it work. I just want to divide these sections up with some lines so that I leave enough room for all the theorems I'm going to need. And I'm going to need 5 more. I don't want to run out of space. Okay. Let's see. Alright. So, if a parallelogram has 2 consecutive sides congruent, it is a rhombus. A parallelogram is a rhombus. If and only if each diagonal bisects a pair of opposite angles. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. Okay. 2 more, and these have to do with squares. Here's the definition that we know. A square is a parallelogram with 4 congruent sides and 4 right angles then it can be rewritten as a quadrilateral is a square if and only if it is a rhombus and a rectangle. Okay, and that's it for this card. Now we just have to talk about the theorems involving trapezoids. Okay. So let's do card 100. So trapezoid and isosceles trapezoid theorems. So the median or mid-segment, hang on a sec. Alright, we'll put it after this. So the median or mid-segment of a trapezoid is a segment that connects, is parallel, we already know what it is parallel to each base and its length is 1/2 the sum of the lengths of the bases. Okay, we might as well just leave that. A trapezoid is a quadrilateral with only one pair of parallel sides. A trapezoid is isosceles if and only if the base angles are congruent A trapezoid is isosceles if and only if the diagonals are congruent. And if a trapezoid is isosceles, the opposite angles are supplementary. So then the opposite angles are supplementary. Okay? So, we're done with our discussion on quadrilaterals. Now that takes us to the next card, which is 101. Alright, in this card we're going to talk about the mid-segment or the midline of a triangle. So the mid-segment of a triangle, which is also called a midline, is a segment joining the midpoints of two sides of a triangle. Okay, the mid-segment of a triangle joins the midpoints of two sides of a triangle such that it is parallel to the third side of the triangle. And the mid-segment of a triangle joins the midpoints of two sides of a triangle such that its length is half the length of the third side of the triangle. Okay, so let's get in a picture of this on the other side. We're going to draw a standard triangle. Okay, let's call it A, B, C. And now let's draw the mid-segment. Let's draw one of the mid-segments. So if this is 4.5, then I want to go to 6.25. This is 6.4. I want to go to 3.2. Okay, so D and E. So, what we know is that since this is a mid-segment, we know that this piece is congruent to this piece because this D is the midpoint of this side, and this piece is congruent to this piece because E is the midpoint of this side. And one of the properties tells us that it's parallel to the third side, so these two sides are parallel. Okay, so let's write down a few things. D is the midpoint of AB. And E is the midpoint of BC. So this line is the mid-segment. Okay? Now, we know that, let me just write here, right above this, I'm going to write DE is a mid-segment. So that means that these D and E are the midpoints. It means that AD is congruent to DB, and it means that BE is congruent to EC. It also means that DE is parallel to AC, and it means that DE is 1/2 the length of AC. Okay? And that's about it for mid-segment. Whoop, let me move that up. Let me just double check. And that's about it for mid-segment.